The electrical potential in SA node is different from that of other cardiac muscle fibers. In the SA node, each impulse triggers the next impulse. It is mainly due to the unstable resting membrane potential. The resting membrane potential in SA node has a negativity of -55 to -60 millivolts. It is different from the negativity of -85 to -95 millivolts in other cardiac muscle fibers. The depolarization starts very slowly, and the threshold levels of -40 millivolts is reached very slowly. After the threshold level, rapid depolarization occurs up to about +5 millivolts. It is followed by rapid repolarization. Once again, the resting membrane potential becomes unstable and reaches the threshold level slowly. This type of resting membrane potential is called the prepotential or the pacemaker potential. The resting membrane potential is not stable in the SA node. To start with, the sodium ions leak into the pacemaker fibers and cause slow depolarization. This slow depolarization forms the initial part of pacemaker potential. Then, the calcium channels start opening. At the beginning, there is a slow influx of calcium ions causing further depolarization in the same slower rate. It forms the later part of the pacemaker potential. Therefore, the initial part of pacemaker potential is due to slow influx of sodium ions, and the later part is due to the slow influx of calcium ions. When the negativity is decreased to -40 millivolts, which is the threshold level, the action potential starts with rapid depolarization. The depolarization occurs because of the influx of more calcium ions. Now, unlike in other tissues, the depolarization in SA node is mainly due to the influx of calcium ions rather than sodium ions. After the rapid depolarization, the repolarization starts. The repolarization is due to the efflux of potassium ions from the pacemaker fibers. The potassium channels remain open for a longer time, causing efflux of more potassium ions. It leads to the development of more negativity beyond the level of resting membrane potential. It usually exists only for a short period, and then the slow depolarization starts once again, leading to the development of pacemaker potential, which triggers the next action potential.